Morning, guys. I'm having technical difficulties. Sorry. All right. Well, today we're going to be comparing rates. That's the slopes of functions. We're going to be looking at graphs. Morning, Javion. We're going to be looking at graphs. We're going to be looking at equations. We're going to look at some tables. We're learning how to find those slopes and then compare them to one another. So I'm going to put my timer on screen, and we're going to wait for a few more people to join up, and then we are going to get started. Morning, Tate. We got about 8 minutes before I'm going to start doing problems, though. Let me get my timer on screen real quick. Yeah, you got time to. Well, I hope you have time to do that. I don't know what her assignments are. Put some notes on the screen so everyone knows exactly what we're doing. This gives me a minute to check and see if anyone has turned in some late work. But we are calling homes. Okay. Okay, chat. few more minutes for people to join up while I go through and see if I can update some grades for people turning in late work. Feel free, if you're on the replay, to skip ahead of watching me look at other screens. It's not very compelling content, I'll give it that. That's the timer. All right, I'm gonna get finished checking this one classroom and then we're gonna get rolling with some practice problems. Just checking one more student's work. More non-queries. Okay. I think I'm done checking work for now. I've got one more class, but I will check it later because you guys are here and it's time to work. Appreciate y'all being here with me. So we're gonna get rolling. Yeah, I got more to check. I'll do it later. Okay. So we're gonna be comparing more functions today. If you were successful on assignment 9, you should also be very successful on assignment 10 because it's the same stuff. Practice makes permanent. Okay. So super quick review of what we're talking about. Comparing rates. So what we're talking about are the slopes of lines. And if you were to be given a XY table like such, or you know what, I'm going to do 4 quadrants for this example. So if you were given a system with your y-axis and your x-axis and your origin, and you had 2 lines going through it, you got one going this way, and you got one going that way. Well, actually, probably better if they're both. Okay. So here's the question. If you were able to see them, and this was line A, and this was line B, and we had to ask which one has the greater slope. Yeah, chat's getting ahead of me, that's right. Which one has the greatest change in Y or change in X? Well, the slope, the rate, those are the same thing. And basically, it's like how fast is the line going up? So Chad, I already have one answer. So here, the question is, which one has the greater slope? What do you think, Chad? Which one? A or B? So I've got the answer B. I've got the answer, the pink one. And you guys are correct. Yes. Now someone might argue, well, the teal line is above it, but it's not going up as fast. You got to remember that slope is the change in Y over the change in X. And when you're looking at it visually, that's basically like which one is steeper, like which one is going up faster. And this one is increasing at a faster rate. So like if we look at in the time interval, like if we look from like, let's say the origin to right here, okay? So we're talking about from here to here, from here to here. Look how much, let me just try that 1 second, undo. So look how much the pink line increases versus the blue line. You'll notice just by looking at these change in Y's, that the pink line is going up by a lot and the blue line is only going up by a little. So that's how you compare them visually. But what I'm giving you this week is not pictures. If it was a picture, you say, well, that one's going up faster than that one. But that's not what you're getting this week. You're getting graphs, you're getting tables, and you're getting equations. So that's what we're going to focus on. How do you know what the slopes are when you're looking at a graph? How do you know what the slope is when you're looking at an equation? How do you know what the slope is when you're looking at a function, like the actual equation? Or a table. And then we'll compare those. So let's get some practice problems on the board. Just had a parent message 1 second. Okay, let's see. These zoom windows that overlap everything can really take up a screen if you're not careful. Okay, so let's see. Let's start off with some equations, I think. Now that it's Wednesday already, there's always the possibility I'm going to use an equation I used in an earlier stream, which is fine. But I wish I could have a perfect memory of which ones I've used. Okay, screen capture incoming. I think we'll change that today. I'm going to grab 2. Let's just go ahead and label these as, we'll say that this is line A and this is line B. And my question is, which one has the greatest slope? All right, which one has the greater rate of change? I got 2 answers from chat so far. We got someone thinks it's B, someone else thinks it's B. Anybody else want to chime in? So I guess what we should ask is, what is the slope of each? Like, what is the slope of A? And just for the record, the letter for slope in an equation is M. Y equals mx plus b. So what's the slope for each? Like, okay, chat, what's the slope for A? Ooh, what's the question? Okay, so I've been told, okay, so I'm getting 2 different answers. I'm getting told that the slope is 2x. I'm also getting told that the slope is 2. And then I'm getting the same confusion here. I'm getting that for B, I'm getting the slope is 9x, or the slope is 9. Do we know which one is right and which one is wrong? Yeah, okay. So we don't want to include the x on that. It's just the coefficient. Coefficient is the big fancy math word for the number that's attached to it. So yeah, so the correct answer is B. That's not what I wanted. Yeah, the correct answer is B because the slope is 9, and that's bigger than a slope of 2 from A, okay? So the lesson here is the slope is stuck to the x value when the equation is written in y equals mx plus b format, okay? It's that coefficient in front of the x. And there was a problem we had yesterday where that number happened to be a 1, and in that case, we probably don't even see it attached to the x because we're too lazy to write it. Let's try another one. You're gonna need some 6th grade math skills to solve this one. If I could drag the window over, that is. What are these two? Yeah, we'll do those next chat. Okay, let's start with A. Let's go ahead and figure out what is the slope. Just looking at the equation because you know how it works. What's the slope for equation A? Good, you're getting better at typing. You're getting better at typing your fractions. Ooh, and simplified as well. Yeah, so get this. So 6/4, which is the same as 3/2. Yep, that is correct. What about B? What is the slope for B? Eight thirds. So now you got to dip back into sixth grade math skills and like, oh, wait a minute. Now, how do we tell which fraction is larger? You need common denominators. So, what's the common denominator between a 3 and a 2 or a 3 and a 4? Looking at the chat to answer this. I've got denominators of 4, 2, and 3. Does anyone have a common number that 3 and 2 go into, or 3 and 4 both go into? Yeah, we can use that. We can use 6 as a common denominator, sure. So real quick mental math. So 2 times 3 is 6. So it's 3. So 3 times 3. So this would be equal to 9/6. 3 times 2 is 6. 8 times 2 is 16/6. So which one has the greater rate? Which one has the greater slope? Okay. So the abstract rule we're trying to use here, there's a question in chat if you're on YouTube wondering what I'm doing. So what we're trying to do here is abuse this rule. Anything times 1 equals itself. So we're not really trying to change anything. Now, there's another rule that says that anything divided by itself is 1. So what we're going to be doing here is we're going to be comboing these two rules together, and we're going to be multiplying something times 1, but we're going to do that in the version of a number over itself. I should use a different letter there. Anyway, the principle is the same, okay? So I have to use the same number on top and bottom for the fractions. And my destination for the pink function for A was to end up with a 6. And the only way I was going to get there was by multiplying 2 times 3. And if I multiply the bottom of this fraction by 3, then I have to multiply the top of that fraction by 3. That's why I multiply by 3's here. Now, I have to look at this purple fraction, like a whole different system. My destination is just end up with a 6. So I have to multiply that denominator by a 2. But if I multiply the denominator by a 2, I have to multiply the numerator by a 2. There are no rules in math that say that I have to multiply the pink part and the purple part by the same numbers. Again, that is a dip back into 6th grade. So what have we done so far? So we've talked about comparing the slopes of functions when you're just given the equation. Now let's look at graphs. As I clear out some scrap work. I might need to get rid of more of this because the graphs take up a lot of room on the screen. We'll see. Okay, so in this case, what we're looking to do is calculate the change in y, the change in x. Otherwise known as the rise over the run. And the way we're going to do this, we're always going to be looking at the graph going left to right. Draw my nice little eyeball there with an eyebrow to match. Anyway, all right, so we're always going to be looking left or right. And that'll tell you whether this is going up or going down. Ooh, good. Chat's already chiming in with fractions. Okay, so the question is, I'm going from dot to dot. How much do I go down and how much do I go over? That's the question. Each square is a unit, so you basically count how many squares you go down. As long as each unit in this case is equal to 1. 1, 2, 3, 4. So I'm going down 4 units. So that's -4. And I'm going over 2 units. So the rise of a run for this function is down 4 and over 2. Okay, so if you were given this graph and being asked to compare it to something else, you need to know that the slope is what? What is -4 divided by 2? My chat answers included a good one. I get someone to give me the correct answer. It's -4/2. But that actually simplifies. So what is the actual slope we'd want to look at to compare to the other fractions, the other slopes, rather? -4 divided by +2 would be -2. So that would be the slope of this function right there. The slope will be -2. All right, chat. And if you have any questions about that, get them ready. I'm going to go ahead and get into the graph. Okay, so if we're looking at this one left, right. Yeah, I think that's what this one actually is, chat. So if I'm gonna go ahead and mark a couple dots on here to make sure it's easier to read for those of you that are trying to squint at your screens. I think those are the only two good locations for us to look at, right there and there. So chat, go ahead and see if you can count it out. What is this slope? I'm gonna write down some chat answers on screen while I respond to some teacher messages. Okay, from chat, I've got 8/3. Okay, chat, I have I have another answer. Now we're gonna actually get my math practice names out because now we're gonna construct an argument. That was the wrong folder anyway. All right, so let's make an argument for what we think is correct. Yeah, okay. So the question is, if we're going left to right, which one do we do first? Now, I remember slope is the change in y over the change in x. Now, y is the up and down value, and x is the sideways value. So you should always measure, like if we're talking about this triangle right here, I'm making this right triangle. So we always want to count the rise over the run, the change in y, the up change goes first. So if that is what I'm supposed to be counting, 1, 2, 3, 4, 5, 6, 7, 8, it definitely goes up 8, and it goes over 3. So this question is, which one of these is correct? Which one is in the correct formation? Yeah, it's 8/3. Yeah, that's what practice is for. So if you were given a graph, what you do is you find two locations. Now this one was a little more difficult because we actually had to find the two spots that perfectly go over coordinates, but we did. And then you count the rise of a run, and that's how you get the slope for that function. So if you had to compare this to something else, that is how you acquire its rate. Okay, now we're going to talk about tables, and then we can get to our assignment for the day. So this is when we talk about tables, we're going to be doing the most of what you guys would probably call math. Because you actually have to do some calculations and be precise. So far, when you're looking at the equation, you just have to spot it. And when you're looking at the graph, you can count it. But when it comes to tables, you actually have to calculate the rate of change. So let's look at this one. No, I'm going to bring 2 on screen. We're going to go ahead and compare 2. Oh, well, it actually won't let me capture twice. I wonder. I can just do it this way. Yeah, that'll work. All right, so here's what we're trying to figure out. Which one of these two has the greater rate of change? We'll go ahead and call this function A, and we'll call this function B. Now, the way we're going to solve this, chat, is that slope is equal to y2 minus y1 over x2 minus x1. And all you are required to do here is really pick, just choose whichever two XY pairs you like the most. No one's going to tell you which ones to choose. Now, I'm just going to go ahead and say that I'm a sucker for low values, and if I can help it, because I yawned twice, if I can help it, I'd rather use positive numbers. Now, I don't always get that lucky, but that's what I would prefer to do. So let's look at function A. Oh, see, since I've got 2 sets right here that are both positive, I'm probably going to go ahead and use those. So if I'm looking at this top to bottom, that means that this will be x1 and this will be y1. Oh, I'm sorry, that'll be x2. Blah, blah, blah. Let me back that up. So the 1 is x1 and the 6 is x2. The 13 is y1 and the 53 is y2. As I get answers from chat, I'll write them down. I'm not sure what you meant by 8. Can you clarify? Let's see. So what we do here, so in the formula, that means that for A, we would do 53 minus 13 over 6 minus 1. So you'd get, oh goodness, 53, I guess that'd be 40 over 5. I guess that's what you meant. Yeah, that's what you meant. So 40 divided by 5 is equal to 8. So I did have an answer in chat, but I didn't know what it meant. So the chat thinks that the slope for A is 8, and they are correct. Yeah, the slope for A is 8. Okay, so now all we have left to do is the same calculation for B. So which 2 would I use for B? Oh, nice. 0. Yeah, zeros make this so easy. So this would be x1, and this would be x2. This would be y1, and this would be y2. Okay, so for my slope for function b would be 10 minus 0 over 2 minus 0. So it'd be 10 halves, which is equal to 5. Yep, so that's right. So yeah, the one with the greater slope is, what was that? Yeah, A is greater. Yep, Chad, you're right. Yeah, A has the greatest slope. So if you were asked to compare rates of change between two things and you were given these tables, that's how you find their slope. Okay, we're running up to about the 40-minute mark, and that's where I like to start putting questions on the board. So let's go ahead and put them on the screen. Say goodbye to you, say goodbye to you. Okay. So let me put some text on the screen. So for people that are just clipping through because they just want to get to the questions, they can find it. Please remember to attach your scrapbook this week. It can be typed out on the Google Doc, and it can be a screenshot, but I need to see everyone's scrapbook to make sure they're doing their own work because last week there was a lot of copy and pasting. Okay. I'll make these easier to look at in just a minute. Okay, while those of you that are here live are starting, I'm going to talk about the answer document and what I'm expecting to see. So on the document, you are told to do a few things. It says this. It says, so give me the slope of function A, give the slope of function B, and then the function with t greatest slope. That's better. Okay, so that's what the directions are. So you're going to go ahead and get the slope for A. And you find the slope for B and type those in. And the third part, your answer is just going to be A or B. That's all you have to do for the third part. All you have to do is tell me which one of the two has the greater slope. So calculate the slope for A, calculate the slope for B, and then just tell me which one's bigger. That's it. So yeah. Well, I guess that about wraps up for assignment 10 in our stream. Excuse me. If you have any specific questions, and you can send me a screenshot or just say, hey, Mr. Matthews, I need help with number such and such on problem or assignment such and such, send me an email. Remember, attach, I'm going to put this on screen too. Attach your scrap work. So unless anyone's got a burning question, I'm going to call it a day and get ready for my next stream. Okay. All right. So take care of yourselves. Take care of your families. Go make your bed. I'll see you guys next time. This will be on YouTube in here in a few minutes in case anyone on stream didn't get a chance to finish one. All right. Bye, guys.